So this is an interesting video because it's something I wanted to make a video on so that you can try to explore the idea of graphing a line without an XY chart. But it's something that I would never know if you actually did or didn't do because you could always use an XY chart to figure out how to graph a line. So this video is about using the y-intercept as your starting point and the slope as your rise over run to get to your next point. And it explains how you don't have to use an XY chart in order to figure out all the points on your line. So it's your choice whether you decide to use this method or whether you decide to stick with your XY chart method, which I know all of you are pretty much masters of at this point. So it does tell you in this video when you can stop watching, but it does extend to about 10 minutes and 30 seconds, but that's just giving more examples than you need to watch. So when the video tells you can stop watching, you can in fact stop watching. Enjoy. So when we look at a linear equation in slope-intercept form, we can recognize it as slope-intercept form because the y is all alone without a coefficient, and it equals the slope, which we use to indicate by m, so slope times x, and then plus or minus b. Okay, so the b is represented by the y-intercept. The y-intercept is something that we haven't talked about in depth yet, but it's basically where the line will cross the y-axis, and a line will only cross the y-axis one time unless, of course, it is the y-axis itself. So when you look at these equations, it's important to be able to identify your m, which is your slope, and your b, which is your y-intercept, so that you can go ahead and graph a line using slope-intercept form. Remember, this will only work when the equation of the line is in slope-intercept form, which is the ones we've been doing so far. So when we look at question number 1, the number in front of x is our slope, so our slope is 2. We can also write our slope as a fraction, which is 2 over 1, because any whole number is as a fraction is over 1. And then your y-intercept, well, there's nothing added or subtracted from x, so then we assume that our y-intercept would be 0. And as a point, that means it would be 0, 0. But the y value of where it crosses the y-axis is 0. When we look at equation 2, our slope or our m is 3. Again, we can write it as 3 over 1. And our b would be negative 4, which means as a point, it would be 0, comma negative 4. So this line is going to cross the y-axis at 0, negative 4. For 3, our slope would be negative 4. And our y-intercept, or our b, would be 0, 1 as a point, and just 1 if we just wanted to know the y value of where it crosses the y-axis. And then in 4, our slope is 1/2, and when it's a fraction, it's kind of cool because we can just leave it as 1/2. We don't have to make it into a fraction. And then our y-intercept would be 0, 3 as a point. Okay, so again, when we're talking about just your y-intercept, you can say 3, but when you're graphing it as a point, you're going to graph it as 0, 3, and we're going to see how that plays a part in a second. So I took the line y equals 2x, and I just want to remind you that slope is rise over run. So when we make it into a fraction, it's very easy for us to tell that we rise 2 and we run 1, because if the slope is 2, 2 as a fraction is 2 over 1, and it's important that we write it as a fraction so we know how much we're rising and how much we're running. And this is going to become clear in the next slide when we actually graph y equals 2x without using an xy chart. The other important piece of this is our starting point. Well, we identified our starting point in the last slide as our y-intercept. And when we look at y equals 2x, it doesn't have a b. I mean, it has a b, but it doesn't have a b staring you in the face. So we know that a b would be 0 because anything added to 0 is itself. So y equals 2x, we could write as y equals 2x plus 0, even though we never would, because why would we ever write 2x plus 0? So here's a coordinate plane, and I'm just reminding you of this y equals 2x equation that we've analyzed in the last slide. We know that our y-intercept is 0, 0 because there's nothing added to x. So I'm going to plot 0, 0. So I'm in the center of my x and y axis where they meet, and that's my starting point. So I'm Pac-Man. I'm sitting at the origin, and now I'm going to look at my slope, and I'm going to remember that my slope tells me that I can rise 2 and I can run 1. So as Pac-Man, I noticed that my rise is positive and my run is positive. So I'm Pac-Man, I'm going to rise 2 and I'm going to run 1. And I'm going to rise 2 and I'm going to run 1. And I'm going to rise 2 and I'm going to run 1. So what I'm doing is I'm going up 2 boxes and over 1 box, and then I'm plotting a point. I'm going to go up 2 boxes and over 1 box, and then I'm going to plot a point, right? So I went up 2 and over 1 and up 2 and over 1 and up 2 and over 1, and that gave me the points that are going to allow me to draw my line. Now notice, a positive rise over a positive run would be equal to a negative rise over a negative run. So negative divided by negative would also give me a positive slope. So I could also go down 2, because that's a negative move, and to the left 1 and plot a point. I could go down 2 and to the left 1 and plot a point. And that would again extend my line. I don't ever have to do those negative moves, because if I do just positive moves and I use my ruler so I don't do a short line, then I would get that line. Notice the steps that I drew in there were just so that you could see how I was moving up 2 and over 1. I don't ever draw those, but it's hard for me to show on this video without doing those steps. I'm going to remember my graph details of labeling my line, and then I didn't have to do an XY chart. If you choose to do an XY chart and you hate this method, go right ahead and keep using an XY chart. I'm going to do a couple of more examples of this. If you'd like to stop watching the video now and you think you kind of got the idea, then go right ahead. If you want to stop the video now because you never want to use this method, go right ahead. But I'm going to do at least 2 more examples of this. So here's the equation y equals 3x minus 4 from the first slide, where we've already identified the slope as 3. I made it into a fraction to be 3 over 1, so I know I'm rising 3 and I'm running 1. That means I just need to know where I'm starting. So I look at my b and it's 0, negative 4. So I go down 4 on my y-axis, and here I am starting at 0, negative 4. That means from this spot, because my slope is positive, I am rising 3. So I'm going 1, 2, 3, and I'm going over 1. And then I'm rising 3, and I'm going over 1. And I'm rising 3, and I'm going over 1. And so that's going to, again, I'm not going to have my steps in there. I could also go down 3 and to the left 1, because it's of a positive slope, I can go 2 negative moves. And if you have a ruler, you're going to connect your dots, and you're going to label your line. So your starting point's your y-intercept, and then your rise is the top number of your fraction, and the run is the bottom number of your fraction. The next slide's going to be a negative slope, and the following slide after that's going to be the fraction. So here's the first model of a negative slope. And what you have to remember about a negative slope is one of your moves has to be negative. So a negative move is down, and a negative move is to the left. You don't want to do both down and to the left, because a negative over a negative is a positive. So that means you can either do down 4 and to the right 1, or up 4 and to the left 1. That's your choice how you choose to do it. So my starting point is 0, 1, and that's because my y-intercept is 1. Now I'm going to show you both ways to do it. So I can go up 4, 1, 2, 3, 4, and to the left 1. Because I went up, that's a positive move. Now I have to go left, which is a negative move. So I went up 4 and to the left 1. I also could go down 4, 1, 2, 3, 4, which is a negative move, and to the right 1, which is a positive move. So I can't do 2 negative moves, because a negative and a negative is a positive. So I need to make sure that I'm doing 1 negative and 1 positive. The other way you can think of it is, you know that positive lines go that way and negative lines go that way. So you could just be like, well, I know my negative line has to go this way, so I'm just going to always move one place that allows me to do that. I can go down 4 again, just so I can extend my line in a better direction. And if you had a ruler, it would look more perfect than mine, and then I would label my line. So it gets tricky when you have negatives, only because you're instinctually, you always want to go up and right when you get into the groove of this, but you have to take note of the fact that when you have a negative, you're going to make 1 negative move. So here's our first fractional slope. And like we discussed when we were analyzing lines, a fractional slope that's positive, it's going to be flatter than the ones that we've looked at. any slope between 0 and 1 is going to be a flatter line, and 1 to infinity is going to be a much steeper line. So we have to make sure that we understand when we see a fraction that it's going to be much flatter than any whole number that's positive. So my starting point is 0, 3. And now I'm rising 1 because it's already a fraction. So my rise is going to be on the top of that fraction and my run is going to be on the bottom of that fraction. So I'm going to rise 1 and I'm going to run 2. So basically, in this case, I am rising less numbers than I am running. And I'm not doing this step just to model for you what happens when you don't do this step, because most lines you see that I've drawn have not had a step in the past. Again, if I had a ruler, it would be nice and straight. And here is my y equals 1/2 x plus 3. I started at 0, 3, and I went up 1 and over 2, and up 1 and over 2, and up 1 and over 2. Remember, I can also go down 1 and over 2, and down 1 and over 2, and down 1 and over 2, and it'll get me the same line. So I've given you examples of all possible different types of lines except negative fractional lines, which is the same as a positive fractional line except in the opposite direction.